Hello and welcome to today's webinar. My name is Tyler Reid. I am the Manufacturing Application Manager here at GoEngineer. And today I get to introduce you to SolidWorks CAM for the very first time. SolidWorks CAM, you heard me right. You have heard me talking about CAMWorks now for quite a few years. And CAMWorks has always been a third-party add-in to SolidWorks. SolidWorks, up until now, really has never had an OEM solution for CAM. But beginning with the SolidWorks 2018 release, they will have a quote OEM solution for CAM, and that is essentially an integrated version of CAMWorks. CAM stands for Computer-Aided Manufacturing. It is what we use to program our CNC mills, our CNC lathes. The output of CAM is a G-code file. SolidWorks CAM is going to be a narrowed down version of CAMWorks. It's going to be the 2.5 axis milling, some very basic 3-axis milling, 2-axis turning, and tolerance-based machining. Now SolidWorks standard, so every seat of SolidWorks, starting with the 2018 release, will have a version of SolidWorks CAM free of charge. That version, as it stands right now, will be the 2.5 axis milling and the very basic 3-axis milling functionality. It will also include the UPG, the Universal Post Generator. It will include potentially a G-code editor. That's coming free of charge to everybody. There will also be a SolidWorks CAM Professional package that comes at a low cost, which will include the 2-axis turning and potentially some other aspects of CAMWorks that has yet to be determined. SolidWorks CAM is being powered by CAMWorks, which means if you are an existing CAMWorks user, SolidWorks CAM is going to be essentially just the same thing you're used to. If you are a CAM user for another package, or if you're new to CAM, you have the benefit of, one, CAMWorks being an easy to use and easy to learn piece of software. 2, it's an intelligent piece of software. And 3, you have the advantage of having us, GoEngineer, as a reseller. That is going to mean a lot because we have been using CAMWorks now for the better part of a decade. That means we're experts in the software, we're experts in training, we're experts in creating post processors so that you can get the most out of this piece of software. Now, this is still in beta. The full release will come with SolidWorks 2018, which is typically in October. But right now it's in beta. There's still a couple things in flux, and you can still sign up for the beta. Right now, if you sign up for the beta, you'll get a download link eventually for the beta program. Once SolidWorks 2018 beta is released, then SolidWorks CAM beta will be part of that. So as soon as you download the beta version of SolidWorks, once it becomes available, you will have the beta version of SolidWorks CAM without actually signing up for the beta program. So we're going to talk about a few of the features of SolidWorks CAM, what's going to make it unique, what's important to know, and then we're going to jump into the software, program apart so you guys can get an idea of what to expect with SolidWorks CAM. SolidWorks CAM, based on CAMWorks, is going to be intelligent machining. It has automatic feature recognition. So when it comes to milling, SolidWorks CAM is going to try to automatically identify 2.5 axis features, flat bottom stuff, things like holes, pockets, slots, bosses, etc. When it comes to turning, it's going to find things like the OD profile and the ID profile, the face and the cutoff, and some grooves. That's level 1 of the intelligence. Level 2 of the intelligence is what we call knowledge-based machining. Once it has these features, either found automatically or manually set by the machinist or the programmer, step 2 is running those features through a database. Now that database looks at parameters of those features and identifies machining strategies. It also learns from you. It learns how you machine your parts on your machines in your shop with your tools. It allows you to save and retain and share that machining knowledge. So if you have a situation where one person is using SolidWorks CAM that is very knowledgeable and has experience machining, and they save their work back to the database, anybody else in that company looking at that database is going to benefit from that machining knowledge. It's also going to help us program faster. We don't have to remember how we programmed a similar part a week ago, a month ago, a year ago, because SolidWorks CAM is going to remember that for us and recall it for us. And for that same reason, it's going to minimize the mistakes and also reduce scrap. So those are the points, the key points of SolidWorks CAM. Let's jump into the software. And we're going to take a look at this part. It's a fairly complex part. It is a chain sprocket of sorts. Notice we are in SolidWorks right now. We're going to go ahead and use SolidWorks CAM to program this. Now, like I said, the milling portion of SolidWorks CAM is going to be included to every user. The turning portion is going to be a minimal cost to users. We don't know what that is yet. It's going to be very affordable. Okay, I'm going to use both turning and milling for this part, so keep this in mind. One thing I'm going to want to do before I start programming is probably simplify the part a little bit. Somebody used the SolidWorks thread wizard to create some threads in this part. I'm going to want to get rid of those before I start CAM programming. I have already done that by creating a configuration called CAM with that feature suppressed. With that, I can move over to the SolidWorks CAM feature tree and the SolidWorks CAM toolbar along the top. This is me moving back and forth between SolidWorks CAM and SolidWorks. Now, if you look at this part, it would probably be best suited if we started with a piece of bar stock, turned it down to net shape on the lathe, and then fed that shape to the mill and did the counterbore holes and the lightning holes, etc. So that's exactly how we're going to program it. We're going to run through this as fast as possible to make sure that we end on time. But this is a fairly complex part. It has some 3-axis features with this sort of tapered wall. So we're going to kind of show as much as we can for SolidWorks CAM. Now, the first thing I'm going to do is switch over to a lathe. By selecting a lathe, it's going to put me in the lathe mode. It's going to create a tool crib for me. It wants to know what tools I have. It will give priority to those tools. It will also choose a post processor. Now, one thing I do have the ability to do is set up a chuck. We can create chucks just from standard chuck shapes. We can load in a part file or an assembly file as a chuck or call it holder, and we can use an STL file as well. I'm just going to keep it standard. We'll go to the wizard and we will bump up the size of this chuck. We'll say it's a 10-inch chuck. Yeah, that looks good. It's got 3 jaws, 2 steps per jaw. We can customize these chucks based on what we have. SolidWorks CAM is going to want to know the chuck definition because it will actually modify the toolpath and check for collisions with the chuck. All right, next thing SolidWorks CAM is going to want to know is the stock shape. Notice it came up with this minimum bounding cylinder highlighted in teal. From there, we can add offsets. I'm going to go ahead and just say this is a 6-inch diameter bar stock. But we can also create stock from sketches and part files, configurations within this part file. We have a lot of flexibility. I'm going to choose solid bar stock, but we also have the ability to create a chord stock like you see there. I'm going to choose the length. It's going to be 1.5 inches. That will give us something to hold on to. And then I'm going to offset that so that there is about 20 thousandths on the face. Okay. So the process here is we're going to start this and we're going to assume that our lathe is just a single spindle. So we'll have to pause the machine, flip the part, and machine the backside. At this point, I'm going to run that feature recognition I talked about. So extracting machinable features is going to look at the faces of the model and identify turn features: OD, ID, grooving, face, and cutoff. It's going to identify setups, which are directions of machining. Because we're going to flip this part eventually, we will have to cut using two different setups. Now on the first setup, it found the face feature, highlighted there in green. It found the OD feature. Notice if I zoom in on this OD feature, how the green profile lifts up off the part. It's looking at the revolved section. So it sees that we have some keyed areas here. It takes that into account when it's coming up with the turn profile. We have the ID feature and the cutoff. With feature recognition, both in milling and turning, it is going to give us a good starting point. There's always going to be some steps that require some filtering. Either feature recognition doesn't find all the features that you want, sometimes it finds too many, and sometimes it finds features in a way that you don't actually want to program them. So there's always some filtering. Another aspect that comes into play here is the strategy that it chooses. Feature recognition always chooses whatever we have set up as the default strategy. Now, a strategy is how we plan to cut the feature. A good example here is the ID feature. If you notice in the brackets, it says ID feature 1, drill. Drill is the strategy. If we highlight this edge, we can see the diameter is 1.3988 inches. That's not a standard drill size. We're not going to be able to just drill that out. We're going to want to change the strategy. So we double click on this guy. We can change the strategy to a rough and finish. This way, it's going to create a center drill and then a drill, 1.25 inches. Then it's going to come in and rough bore it and finish bore it to size. These strategies are one of the key aspects of SolidWorks CAM. That list is totally customizable, which means you as a CNC programmer can save your own strategies, save your work back to the database, so that if you like to do a rough finish on a bore in a particular way, you don't have to remember and create 1, 2, 3, 4 individual steps. You might just create your own custom strategy. I will say I am using just a fresh install here. So everything you see here is the default, which means I would tend to do more filtering than if someone using SolidWorks CAM for quite a while and has been saving their work back to the database would have to do. I don't really need this cutoff feature, so I'm just going to go ahead and delete it. I do need to turn this part around and face the back side. So I'm going to create a new setup, a new direction of machining. And under that setup, I'm going to create a new feature. Now I'm manually creating the features now. We're going to go ahead and tell it to look at the revolved section. The feature type is going to be a face feature, and I'm simply going to select the profiles that I want to cut. There we go. And the strategy rough finish is going to be just fine. So now I have two setups. Under each setup, I have some features. Let's run those features through the database. This database, we call it the TechDB. It sits in the background, and it's sort of the ringmaster for SolidWorks CAM. It lists out the features, and it looks at different parameters. The feature type, the size, the material we're cutting from, the depth, the strategy we've selected. It runs each feature through that database until it finds an entry that matches all of those parameters. When it finds that entry then tells it what operations to create. So it kicked us over to this next tab. We had the SolidWorks CAM feature tree. Now we have the SolidWorks CAM operation tree. Operations are how we're cutting the part. So some examples here: face rough and face finish, turn rough and turn finish. Each one of these contains the tool data. So we have our inserts, our holders, our tool crib, our feed and speed data, the roughing parameters in this case. So we have our first cut, max cut, final cut. We have our allowances, how much material are we leaving on the walls in anticipation for that finish cut, whether or not it's a can cycle, comp on or off. All of the nitty-gritty details of our CNC program are contained within these operations. And I can edit those. Before I edit them, I typically will generate a toolpath. It takes all of the data within these and applies it to the model. So let me explain what we're looking at here. If I zoom out a little bit, the red square is the start of the toolpath. Red dotted lines are rapid moves. If I zoom in, this brown line will be the toolpath, and the blue line will be the shape of the stock as I'm cutting this part. So within turning, SolidWorks CAM will maintain or keep track of the shape of the stock, and it will only put toolpath where there's actual material to cut, and it will never run over a surface that's already to size. So here's the rough pass, and then the finish pass for the face. And then we have the rough cycle and the finish cycle for the OD. Now we do see some interference here. This is why it's helpful to have the chuck displayed. What we might want to do is make sure we move the chuck out of the way. So we're going to go ahead and offset that chuck. Now here's another minor edit we might want to do. If we can see here, the roughing is dipping down, trying to cut that back side of the tooth. It's dipping down as much as it can based on the tool geometry. I might not want that. So I can come in and I can make a slight change. I can change this a couple ways, but the easiest would be just to not allow it to do undercuts. Another thing that you see here is it's rounding this corner, even though the model has a sharp corner. What we're doing is it's a built-in edge break. Now we can tell it to cut sharp corners. Notice I make a change here and I hit preview and the toolpath updates. It becomes a very visual practice to program our parts. I'm going to go ahead and let it edge break those. And I'm going to do the same thing on the finish pass. We're going to go ahead and tell it not to create sharp corners. I can extend and retract these toolpaths. I can essentially shape these toolpaths any way I want. Now this is just an introductory webinar, so I'm not going to be able to go into all the details, but I will say if you are looking at this and you plan on using it, go to YouTube, type in GoEngineer CAMWorks in the search bar, and you are going to find a lot of different videos that I've been doing over the years on the CAMWorks product. All of those are going to be applicable to SolidWorks CAM. It's going to give you a great jump start on using this program. And we have a center drill and a drill. Here's another scenario where I might want to extend this toolpath. Notice it's just going to the end of the part. I want to override that depth to make sure this drill goes all the way through the part. I can do that. I can add the tip length. Gets me to where I want. I can also just override it a little bit more, and that's going to get me exactly what I want. If I want to go all the way through the stock, I can do that as well. I can just add a few more hundredths of a thousandths, and now we're all the way through the stock. We see that through the blue bar. We might do the same thing on the boring cycles. We're just adding end length here. On the bore rough and the bore finish. I'm just adding a ½ inch. Now, if that's something that I never wanted to actually manually do, I always have the option of coming back to my feature and saving my operation plan. I can save my work back to the database. When I save this, it's saving, in this case, anything I make changes to with the center drill, the bore rough, and the bore finish. That's the first side. Now let's look at the back side. Again, I'm going to have to adjust where my chuck is. So we're going to go ahead and tell it to clamp on that edge. And we are going to adjust it like that. Okay. And on the back side, we just have the face rough and the face finish. Now let's simulate this. As we simulate, we're doing collision checking with the insert and the holder and the chuck. That ran through very quick. You can adjust the speed if you'd like. Once we're done with the simulation, we can run a comparison, and it will color code the model as we've cut it against how it's designed in SolidWorks. Wherever we're blue, there's still material left to cut. If there's any warm colors, reds and yellows, that would mean we're overcut, and anything green is considered right on. So this is a very rapid way to get a sense for what we've cut and how accurately we've cut it. One thing we haven't done is that threaded portion on the ID. So let's go back to our feature. I don't have to recreate that feature. I can just add more operations to it. So we're going to go ahead and add a threading operation. And the first thing we're going to do is it gave me a warning saying the tool is not in the correct orientation. So we're going to go ahead and adjust the orientation here. See, the threaded insert is now in the correct orientation. We might also adjust the holder. Let's use a bit thinner holder here. Okay. Now I just typed in some values, but realistically I'd probably want to go through and adjust a new tool assembly, which would be a holder and an insert together. But for now I'm just going to go ahead and overwrite those values. Next, we need the thread profile. Based on the diameter of the feature, it will take its best guess as to what sort of thread I want. And in this case, I'm not certain it selected the correct one, so I'm going to go to my thread database, and I'm going to go ahead and select my UNF. So it guessed a UNC, a coarse thread. And in reality, this was a UNF 1/2 12. So all I need to do is select it from that built-in library, hit preview, and now we got our toolpath. When we preview this now, we can see the threading there was simulated. When we run our comparison now, we can see it cut into the model. We are getting some overcutting now because the model is done up to be the minor diameter, and we are cutting these threads in. So we're overcutting compared to the SolidWorks file, but that's exactly what we want. That's perfect. Last thing we're going to need to do is insert a stop. So we're going to insert a post operation, a program stop, and we're going to pull that down. When we post out this code, it's going to post out in the order we have it. We can drag and drop these. We can also sort these with a command. This post operation is when the operator is going to flip part. That way, when I post this out as all a single program, the machine will stop in a safe place. The G-code will tell the operator to flip the part, and then he'll hit resume on the back side. Now the output of this is the G-code, as I mentioned. We're going to go ahead and generate this G-code. So this here is the output of SolidWorks CAM. In this case, it's just a text file. It's using a generic post that installs with SolidWorks CAM. This is the file that we're going to take to our CNC machine to run the code. Now at any point, if I have, say, multiple lathes and I wanted to output to a different machine, I simply change the post processor to another machine and then repost the code. All right, so there's the lathe portion of this. Pretty quick and easy. One thing we did discuss doing was saving that shape off the lathe and loading it in as the stock for the mill. So we're going to go ahead and do that. What we do is we simulate it one more time. And once that shape is simulated, we can save that shape out as what's called a work in progress file, or simply an STL. We go ahead and save that. And now let's create a new configuration. So just like in SolidWorks, we can create configurations within SolidWorks CAM that's going to allow us to have multiple versions of the CAM data within the same part file. That's key because all of the CAM data is in the part file. Now in this case, we are going to keep the machine as the mill. Let's just double click on there and make sure we've got a mill. It's got our tool crib, our post processor selected. For the stock, it wants to create this minimum bounding box, but instead we're going to tell it to read an STL file, and we're going to browse to that STL file we just saved. So notice now the preview of the stock is much more accurate to what we're actually going to start with. This is important for simulation and also for making sure that we have efficient tool paths. One thing I haven't mentioned is the default material right now is 6061, and I'm not changing that, but we do have a whole library of about 1,000 different metals and some plastics, and all of those have custom feeds and speeds built into them should you want to use it that way. I'm going to set my work coordinate to be just the top center of the stock. That seems like a good place for me to touch off. And now let's again run through the automatic feature recognition. So just like with turning, this is going to deliver some features that we will then filter out. This especially will result in some extraneous features because we're not starting from a standard stock. We're starting from the turn portion, and this technology doesn't look at the stock shape when it's developing the features. So it created one mill part setup, one direction of machining. From there, it found the perimeter. We'll use that. It found the face, the top face. We're not going to use that. It found that center hole. That's already cut. Found these counterbore holes. Now notice it says counterbore hole group. So not only did it find it, one, as a counterbore, which is awesome, instead of finding it as, say, a pocket with a hole in it, but it also grouped them together because it recognizes they're the same depth and size, and it assumes correctly that we're going to cut them similarly. And then it also found this second hole group. So it found pretty much all I wanted with some extras. So I'm going to delete that face. I'm going to delete this hole. And we're going to run with this for right now. Portions that it didn't find were these faces. Those are 3-axis faces. It typically won't find those. So we're going to go ahead and just run with it for now. We're going to generate operation plan, which is running those features through the database. We're going to generate toolpath on what it found, and we'll just kind of take a look at what it did. So here's the perimeter. It's basing the perimeter off the total height of the part. We don't need that. So let's come in, and we can limit it pretty easily. We can set upper and lower Z limits. We can adjust the feature size. We can adjust the depth of cut. We could do this several different ways. The easiest way that comes to mind is probably just adjusting the depth of cut. Right now it's doing 1/4 inch. If I just give it a large number, it will cut everything all in one pass. That's one way of doing it. If I want to make sure that the pass goes a little bit deeper than the part, I can do that by overriding the depth. We'll say this is an extra 20 thousandths. So now when I hit preview, you can see the toolpath is slightly below the part. We probably have an issue with tool accessibility. If you look at the size of my tool, the tool is following my cursor. It's larger than the teeth. So I'm going to go ahead and change the tool. We'll go to my tool crib. This was a 1/2 inch end mill. So let's go to my tool crib and we will select a 1/4 inch end mill. Hit preview. It's looking pretty good. Another thing I might want to do, since this is a finished pass and I might be concerned about the surface finish on those walls, I can add a second pass. We'll give it a final cut of, say, 5 thousandths. And what you'll see now is that it will do a rough pass and it will step in in the XY plane and do a finish pass for the last 5 thousandths of an inch. So if we zoom in here, we see we now have 2 paths in X and Y. Great, I'm pretty happy with that. I'm going to go ahead and hit OK. And we will move on. We have a center drill operation on the counterbores, and then we have a drill operation on the counterbores. If we look at, these are through holes, and our toolpath is going beyond the bottom, so it recognized it as a through hole. And then we have a finish pass cutting the counterbore itself. Now here's something where I might want to make a change. It's coming straight down in, it's plunging, and it's stepping outward. I might have it interpolate down. I can add an angle. We'll ramp it down at, say, 10 degrees and cut it more like a spiral. Then it's coming in with a countersink tool to edge break that top edge. And then it's coming down and edge breaking again. Here's something that's a little funky in the TechDB. It's edge breaking it twice. I don't really like that. So I don't have to deal with it. I can delete that second edge break. Now I've made a change to how I cut these counterboard holes. I've made a couple changes. One, I'm only edge breaking it once. And two, I'm interpolating down in that counterboard hole. I want to do that more often. And so I'm going to save my operation. I'm going to overwrite the existing condition. And now I've just taught SolidWorks CAM how to cut these counterboard holes. I don't have to ever make those changes in the future. And then lastly, it's going to drill out these outer holes. It's center drill and drill. So let's simulate this. There's the outer profile, the rest of the holes. Looking pretty good. All right, let's tackle this outer portion now. There's a couple different ways we could do it. I'm going to use a combination of 2-axis and 3-axis tools. So I'm going to go ahead and create a new 2-axis feature. In this case, it's going to be what's called an open pocket. We're going to essentially cut this face. Now, I'm going to set the depth of the feature just by clicking on a face. That parametrically creates that feature and sets the depth so that if that face ever moves in the future, my SolidWorks CAM feature will update with it, and therefore my toolpaths will update with it. So essentially what we've done is we've created this volume of material we want to cut away, but there is a giant island in there. So we're going to go ahead and select that loop and tell SolidWorks CAM to avoid cutting within that loop. And we are going to add a taper so that it matches up with the part. Looks like a 15-degree taper. We're going to go ahead and run that through the database. It will create a rough mill. We'll generate some toolpath. And there is our roughing pass around that area. Now, how rough is it? We can control that. We can tell it, leave 0 allowance on the bottom. So we are cutting to the bottom. And we are leaving 100 thousandths on the sidewalls. Totally customizable, but we're going to go ahead and just leave that there. So if we simulate this guy, let's just simulate that one pass. That is essentially what our rough pass is going to do. So now we just need to do a finish pass. I am going to show you guys what sort of capabilities we have with the 3-axis. We're going to go ahead and create a 3-axis feature out of our entire part. And we're going to create what's called a Z-level operation. So with the 3-axis SolidWorks CAM, we have 3 operations available to us. We have area clearance, which is a 3-axis roughing. We have Z-level, which is a finish type of operation. And we have flat area, which is also a finish type operation. The full-fledged CAMWorks product has about a handful more types of operations for finishing that are all geared towards, different types of geometry. But Z-level is actually a pretty good fit for this operation. We're going to select a ball nose end mill. Within my tool crib, I'm not sure I have very many ball nose end mills. I have 1 3/8 inch. I want to do something smaller. I'm going to go to the tool library, which is a much larger database. We're going to look at ball nose tools. We're going to limit the search to tools under 1/4 inch. And here's all my ball nose end mills out of my tool library that come loaded up. We're going to go ahead and select a 1/8 inch tool. Now, I created a feature out of my entire part. That's just going to be the simplest way of doing it. I'm going to go ahead and hit preview to show you what that looks like. It's going to be a lot more toolpath than what we need. In this case, it's actually not too bad, but it's creating toolpath in these areas and outside here. So we're going to do a couple things. We're going to use what's called contain and avoid areas. We're going to say create a new contain area on that face. And then we're going to create an avoid area on this face. And that is going to limit the scope of that 3-axis feature. All right? A couple more things we might want to do. There's some unnecessary lifting there. So we're going to go ahead and make some adjustments. We will tell it can cut a little bit finer. We'll say 50 thousandths cuts. Something like that. Let's simulate this entire guy. Now, outside of making sure our orders of operations are correct, and ooh, there's an issue there. Red's bad. This is why we simulate. The tool stick out is not great enough. And we could probably do a finer finish on that surface, right? So let's make a couple adjustments here to our finish pass. One, we were getting some collision. So on our tool, let's make sure we have more than just a 1/2 inch stick out. Let's do, say, 2 inch, 1.5 inches. That should be good. And on the Z level, let's do 10 thousandths cuts in Z per pass. We'll let this regenerate. But we're basically done here. We've got the lathe portion. We've got the mill portion. It's all simulated using the correct stock shape. All that's left is posting out the code and sending it to our machine. This is all done with either the base SolidWorks CAM or what will be known as SolidWorks CAM Professional. Again, the lathe portion is the SolidWorks CAM Professional. Let that finish simulating so we can run one final comparison. We're looking pretty good. Pretty good. So that's going to do it for this introduction to SolidWorks CAM. I hope everybody is excited as I am. If you don't have a CAM tool yet, or if you're using another CAM tool, but you really only have the 2.5 axis and some basic 3-axis work to do, you are now going to have a free option built right into SolidWorks that's supported by the OEM, that's developed by the OEM. It's going to be a great tool for all of us. It is powered by CAMWorks, so us at GoEngineer are excited about that because we know CAMWorks inside out. We've been using it, supporting it, and pushing the development team for 10 years now. So I want to thank you guys for joining. And if you want more info, stay tuned for more SolidWorks CAM beta videos, but also check out all of the old CAMWorks videos I've done in the past. Thanks. Bye.